In general, we know when our technological systems stop working. There may be a flash of light when we least expect it, or, as in the case of a ceiling lamp, there may be no light. There may be a burning smell or a strange sound. Technologists have special ways of measuring whether technical systems are working properly. They can do clever things like measure power consumption, strength of radio transmissions, level of sound output, and temperature. Those measurements do not, however, tell us whether our technological systems are serving our needs. How would we, as designers of technological systems that are intended to support human cognitive work, assess whether they do actually support cognitive work? This issue, how we can assess whether the systems we design support cognitive work as we intend, is the focus of my presentation today. As suggested by the graphics on this page, I will work through three perspectives. I will start with a discussion of cognitive indicators as developed within the field of naturalistic decision-making. I'm indebted to my friend and colleague Cindy Dominguez for bringing this work on cognitive indicators to my attention. It was this work, as Cindy described it, that motivated me to think more systematically about how I had been using the decision ladder to develop what I called cognitive task observables. While cognitive indicators and cognitive task observables suggest ways of assessing cognitive support tools, they do not address the overall health of the system. To do that, I will illustrate how I develop cognitive system observables from the abstraction-decomposition space of work domain analysis. But first, I will start with cognitive indicators. Cognitive indicators assess how well cognitive tools support, or possibly hinder, cognition in natural settings. They are a set of measures that have been abstracted from a review of cognitive systems engineering literature. Those who work in this area talk about distilling cognitive engineering expertise. Thus the graphic of a still in the upper right-hand corner. I should stress that this is about assessing technology and not about assessing cognitive capabilities of workers. We are investigating how well our technologies support cognitive work and not how well our workers use the technologies or how well they think. The published source for this work is a chapter by Sterling Wiggins and Donald Cox in this book by Emily Patterson and Janet Miller. The chapter identifies 11 cognitive indicators, although other informal documents refer sometimes to 9 indicators and at other times to 13. In this presentation, I will stay close to the Wiggins and Cox chapter by discussing their 11 indicators. Those 11 indicators are listed on this page. In just a moment, I'm going to give you an opportunity to review this list. However, before I do that, I would like to prime you to look for a couple of things. As you are reviewing the list, note that some of these are about information and some about execution. This list is not ordered in that way, but I think you will see that it could be. Additionally, one of these indicators describes cognitive performance at a higher level of abstraction than do the others. I will explain that in a moment, but you might see if you can identify the particular cognitive indicator that I'm talking about. At this stage in the webcast, I paused until everybody indicated that they had gone through the list. I have edited this part of the webcast to delete that rather long pause, and at this moment you could pause the recording yourself to review the page. Restart the recording when you are satisfied. I'm always troubled when I see long lists like this. Remember Miller's 7 ± 2 constraint on short-term memory. I always wonder if there is a way to structure a list like this to make it easier to assimilate. In the following 2 slides, I have used the information versus execution distinction to sort the indicators. On this slide, I show the 7 indicators associated with information. Note one other thing. I have moved situation assessment to the top and set it apart in larger font. The other 6, cue prominence, direct comprehension, historic information, fine distinctions, transparency, and anticipation, support situation assessment. Situation assessment would seem to be an umbrella indicator, or an indicator at a higher level of abstraction than the other 6. On this next slide, I show the 4 indicators associated with execution: workability, directability, procedural flexibility, and adjustable settings. However, there is no umbrella indicator for these 4. I have made one up and called it execution, but I show it in lighter typeface to signify that it is not, or at least not yet, a real cognitive indicator. And so this is my list of cognitive indicators with, of course, considerable intellectual debt to Cindy Dominguez and her colleagues. One thing that's worth pointing out is that this list is unlikely to be complete. If you're going to use cognitive indicators to assess the adequacy of your cognitive support tools, you should feel free to think about other possibilities. For example, when I'm working on my computer and I want to use speech input, I'm more likely to do that if the speech recognition software is already running and my microphone is already on. I am more likely to use this support tool if its use is seamless within my current workflow. So, seamless within current workflow is an indicator that I might want to add to the list. I now want to move into a discussion of some elements of cognitive work analysis to demonstrate that there is a somewhat similar but better structured argument for cognitive performance assessment that can be derived from a consideration of the decision ladder. If you've not encountered the decision ladder, you should possibly halt this movie and read a little on it before continuing. The tutorial on work task analysis from the tutorials page of my website should suffice. Here I show the decision ladder with an emphasis on the 3 main stages: situation assessment, options analysis, and planning. You will see that the main stages of the decision ladder map at least partially into the structure of the cognitive indicators. There is, however, nothing in the discussion of cognitive indicators about options analysis. Coming, as it does, from the tradition of recognition prime decision making, that's hardly surprising, although note that those who work in the area of recognition prime decision making do not exclude the possibility of options analysis. In my use of the decision ladder, I want to remain sensitive to the insights coming out of the situation awareness and recognition prime decision making research, but with the goal of accommodating all types of work processes and strategies, I want to retain an explicit reference to options analysis. Thus, I show 3 basic categories for cognitive performance assessment, those being situation assessment, options analysis, and planning. On this slide I show a rating scale I developed for assessment of a control station for an unmanned air vehicle system. The mission controller is asked to assess how well the mission workstation supports situation assessment, options analysis, and planning during the sequential phases of the mission as shown along the top of the rating protocol. Of course, the mission controller may not engage in options analysis in particular, and so, for those cases in which options analysis, or indeed situation assessment or planning, are not relevant to that part of the mission, the rating will indicate that. For cognitive processes that are relevant, the rating will indicate whether the mission workstation supports that particular phase of the mission well, poorly, or not at all. In cases that the mission workstation does not provide adequate support, we will want to know more. We will want to develop a diagnostic assessment that will show us what is wrong with our cognitive support system and how we might fix it. To that end, I turn to a more detailed consideration of the decision ladder. Note that the decision ladder consists of a constellation of cognitive states linked by cognitive processes. The implication of the decision ladder is that this is the complete set of cognitive states and processes that could potentially be involved in cognitive work, although that claim should not be taken as implying that all cognitive states and processes are implicated in all work tasks. As depicted in the ladder, cognitive states are transformed by the action of cognitive processes. Following the inspiration of the cognitive indicators work, let's consider assessment of these cognitive processes as a route into diagnosing why the mission control system might not adequately support situation assessment, options analysis, or planning. Here I subsume the cognitive processes as identified in the decision ladder under those major categories. This set of cognitive task observables is more structured and more comprehensive than the cognitive indicators offered by Wiggins and Cox, although note that they are also of a different form. In a lot of circumstances, you might want to employ both of these approaches to assess how well a technological system supports cognition. Now I want to transition into a discussion of a different type of assessment tool. Here I'm going to show you how to assess the structure of a cognitive system, and will turn to the abstraction-decomposition space as a guide. If you are not yet familiar with the abstraction-decomposition space, you might at this time pause the video and read my tutorial on work domain analysis, which is also available from the tutorials page of my website. On this page, I show a small part of an abstraction-decomposition space for counterinsurgency operations. I developed this abstraction-decomposition space from a book called Joker 1, which is a narrative about US Marine counterinsurgency operations in the Iraqi city of Ramadi during 2004. The author of this book, Donovan Campbell, was a platoon leader, and the book is about his platoon's experiences throughout intensive insurgency actions in Ramadi. This particular fragment of the abstraction-decomposition space focuses on a mission that Donovan Campbell set up to ambush insurgents as they met at the Ramadi railway station. At the top level, the abstraction-decomposition space identifies security and stability as the purpose of the counterinsurgency operations. At the second level, it identifies the values of sanctity of human life and mission focus. The purpose and the values are abstracted from the narratives in the book. Campbell's platoon was involved in tactical operations, and the ambush is just one of the many missions his platoon executed. The ambush mission is supported at the lowest level by physical resources and, at the next level up, by the technical functions of those physical resources. These 5 levels of abstraction describe the system in different terms, and I will refer to each of these 5 levels to develop assessment tools. In summary, before I get into specifics, we want the system to support realization of the identified purpose. How might we establish that the system does that? We also want to ensure that the use of the system does not result in violation of the values. How might we establish that? If we can indeed establish both of those things, we have possibly done enough. The purpose is satisfied and the values honored. Of course, if we find that we cannot always satisfy the purpose, or that we sometimes violate one or more of the values, we will want to know why. Is it because of the system? We want to be more diagnostic, and measures at the 3 lower levels should serve us in that regard. Do we have the physical devices or physical subsystems we need? Are they configured properly? Do they provide the technical functions we need, and do those technical functions provide adequate support for the mission functions? Measurement at the 2 lower levels is straightforward enough. Technical people do these sorts of things all the time. Is the radio working? Is it compact enough and light enough to be carried by a Marine? At the physical resources and material level, we might rely on technical measurements, inventories, and perceptual inspection. This green-colored call-out refers to pages in the book where just before departing on the ambush mission, the Marines inspected their gear. Did they have everything? Was it in the right place? And did it appear to be in good order? At the technical functions level, we again might employ different kinds of technical measurements, and some sort of modeling tool might also be useful. The green call-out refers to a discussion of the performance of the personal role radio. The platoon was divided into 3 squads, and each squad had one of these radios. The Marines moved by foot to the ambush site, and as they did so, the 3 squads were separated by a distance that Campbell assumed would be in range of the personal role radios. His assumption was based on his pre-deployment experience during training exercises in the US. He discovered during this mission that the radios did not perform as well in this environment as they had in the training environment. This suggests that the technical performance of this device was inadequate. Measurement at the 3 upper levels may seem less straightforward, but I will illustrate some of the ways we might approach this. At the mission function level, we might use operational assessments and assessments of own casualties. Possibly the discovery of enemy weapons could figure into operational assessments, as suggested by the successful search described on page 281 of the book. At the mission values level, we might rely on command reviews and civilian casualty assessments. At the mission purpose level, we might rely on political stability assessments and security reviews. Especially at these 3 top levels, the nature of the specific observables may not be immediately apparent. I will focus on the mission purpose level to illustrate in more detail. This slide shows some ideas that came out of a piece of work in which I developed a prototype for an information workspace for counterinsurgency operations in Iraq. The workspace depicts information that is needed at both strategic and tactical levels. The figure in the center has 5 axes. Each axis presents a dimension. For example, functional public and commercial infrastructure. The dimensions are normalized so that a politically stable and secure situation will be represented by a symmetric figure. Deterioration on any dimension will result in a distortion. Interrogation of the problem axis will foreground more diagnostic information about components of that dimension. Note, for example, the histogram, linked to the dimension of functional public and commercial infrastructure, as a technique for displaying more diagnostic information. Some of the components of this dimension are shown to the left of the slide. Regular and stable service for electricity, telephone, water, gasoline, and public transport, for example. This is the last slide, and I will summarize. I started by observing that we need to ensure that cognitive support tools provide good support for cognitive work. The common approach is to be satisfied if the code works and if the technological system functions as designed. For a cognitive support tool, that is necessary but not enough. I introduced the work on cognitive indicators and argued that while these are interesting, evocative, and useful, the list lacks structure and is incomplete. From there, I moved into the decision ladder to identify 3 high-level observables: situation assessment, options analysis, and planning, and then teased out the cognitive processes that support them. I also demonstrated how we might develop a rating scale to evaluate a system on the basis of those observables. Finally, I argued that we also need to be able to assess system performance, and I referred to the abstraction-decomposition space of work domain analysis to identify observables at the 5 levels of abstraction. I will not argue further about which of these approaches you should employ. That will generally depend on the type of problem you're trying to resolve. I do think it likely that a large-scale project will require some combination of all 3. You may even find a different method that satisfies your need. However, remember the underlying theme of my presentation. Technical measurements are not enough. You need to identify some way of assessing whether the cognitive support tools or the cognitive support systems you design actually support the cognitive work. Thank you for your attention. If you have any comments on this presentation, please email me at the address shown on this slide.